Hello, everybody. So today we're going to talk about how to write your own scikit-learn estimator. How many people in the room understand that sentence? Good. Cool. Um, the this has like this. I gave a version of this talk about like 2.5 years ago, and that motivated a lot of development that I drove inside scikit-learn. And then I realized, well, my talk back then is not valid anymore. Things have improved, so I thought I can like give an updated version of the talk. But if you ask me how should you write a scikit-learn estimator, one answer could be that, well, go to this page, which explains developing your own estimator. It's it's not that short. It is very extensive. It talks about what's an estimator, what does it mean to fit, what are the estimated attributes, a bunch of explanation, what's get params, set params, what's cloning, what are estimator types, what are tags, a whole bunch of stuff. What's check is fitted, the HTML rep, and all of that. But let's be honest, I don't think anybody's gonna go read that page to develop their estimator. So there is an alternative way of doing that, and that's what we're gonna explore in this talk. By the way, like I'm Adrin, I work at Probable these days. I'm one of the maintainers of scikit-learn, and you have this talk and all the past versions on this GitHub repo. And since you know scikit-learn, I'm not going to talk about that. But what are some of the main components inside scikit-learn that most users would be exposed to when you write code that uses scikit-learn? You have most of your estimators, like logistic regression, your random forest, your his gradient boost, all of those. You have your scorers, your R2 score, and your root mean square, and like everything that's there. You have your CV splitters, k-fold, group k-fold, stratified, shuffle split, like all of those objects. And you have a whole bunch of meta estimators, which include pipeline, grid search, and column transformer, to name a few. And what would a pipeline look like? If I were to write a very simple pipeline, it would look like this. I'm handling some text. I have like a count vectorizer, a TF-IDF transformer, and an SGD classifier. If I want to pass that pipeline to a grid search, how do I pass my parameter grid? Kind of with this syntax. I have names, the name, dunder, and then the parameter name. Easy. But pipelines in more real use cases could be a lot more complex. This is from an example we have, which analyzes some text. It extracts the subject body from an email. It does some column transformation there. It has some custom transformers, like text stats transformer. And at the end, it's this like very long object. So what is this talk about? This talk is about how you would write these transformers that are your own instances of your own transformers, or in general, estimators. Why would you write your own estimator? Well, first of all, we don't include every single algorithm out there. We actually have a ridiculously high bar for including algorithms, and a part of that is it's impossible for us maintain the library if we had every possible algorithm out there. To the point that like our documentation says you need to, like the paper talking about the algorithm needs to have at least like 200 to 300 citations. These days, even that might not be enough. So you might want to take an estimator, modify it it might work for use case, or you're a researcher and you want to have something that other users can actually use. Also, we don't include anything that has a very small scope. And that is usually the case if you deal with some real data. You have something that works only for you or like in your company, but not for everybody, like that many people out there. And that means that those things are not going to be inside scikit-learn. So you might create your own Lego pieces for your use case. Also, like for whatever reason, audit reasons or I don't know, logging, you might want to add steps to the to an estimator. You want to log the time that it took. You want to like log the data that was fed to an estimator, but you don't want to modify the behavior of the estimator otherwise. So you might want to write a meta estimator to wrap around what's available in scikit-learn. Also, please do ask questions at any stage. Otherwise, I tend to go too fast. So I need you to ask questions when you don't understand, and that's my fault if you're not understanding them. What's the basic API? Like the basic API that you're probably familiar with is like calling fit, calling predict. You have transform, and estimators also like the predictors have also a score function. And when you start developing your estimator, that's where you start with. But is that enough? And that's what we're going to find out. Here, we're going to start with, and we're going to do that together, so it might take a while. We're going to start with a custom classifier. And we know a little bit, so we know that a classifier should inherit from base estimator and classifier mixin. In fit, this is a dummy classifier. I'm not doing much. I just want to store what the classes passed to my classifier were. I don't really actually learn anything. And then in predict, I return only the first class. It's dummy, sure, why not? But let's see like how far we can get with this implementation. Something you can do in scikit-learn is, also, is the text large enough for people in the back? Good. Sure. Better? Cool. We have this utility function check estimator that runs all our common tests on your estimator, and it gives you a lot of information about what's wrong and what you need to do. So let's run that on an instance of my classifier and see what happens. As basically expected, it raises a bunch of errors, and ideally these errors are going to guide you to fix your estimator. And let's go through a bunch of them and like fix what we have. The first one says estimator adds public attributes during fit method. Estimators are only allowed to add private attributes, either like started with underscore or fitted attributes that end with an underscore. What is this talking about? It's talking about this targets variable. So we need to make it private, and like by private, it's just a convention we have. It means like start this thing with 1 underscore, it makes it private. So I change that also here, 1 underscore. Let's run the test again. It gives me an assertion error. It says, well, estimator.fit, the output of this should be estimator. This is because our fit didn't return self. Okay. Fix that, run it again. Now, a bigger one. Estimator should raise a not fitted error when calling predict before fit. How can you do that? You can call check is fitted self. Okay, I know how to do that. Which means in predict, we should call this. Does this fix the issue? It raises a different error, but it is basically the same error. It's like, well, the instance is not fitted yet, but I just called check is fitted. The thing is, check is fitted checks if your instance has at least 1 attribute ending with an underscore. Those are your fitted attributes. And I don't have that. I have one that starts with an underscore. Well, let's make it public. Why not? It's a fitted attribute. Or no, like an alternative is I don't want to make it public. I insist I want it to be private, but I can modify the way check is fitted work. I can do that by sklearn is fitted. And I say return has attribute self underscore targets. This should give me a different error now, hopefully. Yeah, it does. Yay! So now it says fit does not set the end features in attribute. This is something that in newer versions of scikit-learn, if you're using something like maybe it's 3 years old, you probably won't be getting these errors. But now estimators actually store what kind of data, what was the shape of the data, like shape in terms of how many features they had, like that was given to them during fit. How can I fix that? I need to call this validate data. Okay, I can do that. How do we do that? We say x, y, validate data, self x, y. Now it says predict does not check for consistency between input number of features during fit via this attribute compared to when predict was called. And it also tells you basically your code should look kind of like this. In your predict, you need to have this line. I'm like, okay, I can do that. And also this reset tells this validate data that like I'm just checking things, don't set those attributes for my estimator now. Now it says I have the wrong inheritance order. I'm inheriting from the right classes, but classifier mixin should come before base estimator. There are reasons why these matter. Trust me, you don't want to know. So let's fix that and see what we get now. Oh, now it says my classifier object has no attribute classes. This is a part of the API. All classifiers should fit a classes underscore attribute, which stores the classes that was given to them during fit. Like, oh, okay, so in the end, this targets has to be called this, which also means I don't really need this now because now I do have something that ends with an underscore, but I can keep it. Why not? And then here I do that. Another assertion error. Now it says your accuracy score is not good enough. Well, I know it's a very dummy, stupid estimator. How do I fix that? You either fix your estimator or you might know that sometimes it doesn't, or on small data or on the data that is available in test, it doesn't work that well. Now we get into tags, which talk to certain utilities in scikit-learn and also the whole like testing mechanism in scikit-learn. Let's customize that. Tags, how do we do that? We get our tags from my parent and change that. We say tags dot, I think, classifier tags, if I don't have a typo, poor score is true. What do I have now? Oh, yes. So that fixed that issue. It basically skips that test. When a classifier is passed continuous target, it should raise a value error. Okay. So like you need to do that test. The error message is not as good as the previous ones. It should ideally tell you how to fix it. And the fix is actually here. I can call check classification targets. Why? Good. What do I have now? What? Something went wrong. That's why you always have a solved version. Oh, that's true. It doesn't have an output. Well. Good. Now it passes. It passes and it gives you a list of tests that were passed, or if they were skipped, it also tells you if they were skipped. You can use this in like if you actually care about the tests. Okay, good. This is the first estimator that we wrote. Questions? No. It raised an error because it was something that didn't start or end with an underscore. Like the convention is that fitted attributes that are a part of your public API end with an underscore. Yes. Yes. The question, the question is, what does this poor score does? Let's look at the error again. If I comment that, the error that we get, this is the error. We are training the instance that was passed to the test on some data, and we expect the accuracy score returned by predict method of the classifier to be higher than this very arbitrary value. And this arbitrary value is there because all scikit-learn estimators pass this. But I know for some reason my estimator doesn't pass that. And if you look at the line before that, is like it checks this precise tag. Tags does classifier tags poor score. So now I declare that this classifier will sometimes return a bad score. Anything else? Good. So like the three utility functions that we used was check is fitted, validate data, that if you're familiar with check array, which is kind of the old way that you were recommended to check your input data, now you call validate data, which calls check array. If you want to call validate data in order to store the number of features and all of that, but you don't want to call check array, there is this skip check array flag here, and everything else that you pass here will be passed to check array. So like you have all the options you have there, also here. And then check classification targets just like checks what the target is. Okay. An alternative way to run the tests, if you're using PyTest, is this parameterized with checks, which takes an instance of your estimator and also a callback that the callback would take the instance and return the tests that are expected to fail. Sometimes, so here one test failed and we fixed it or skipped it by declaring that like we might have a poor score, but sometimes for some reason there might be some other tests that you just like are not going to pass. You can return that list here, and then they will be skipped. And then the way that the code would look like is this. Like you easily like create a PyTest, and then this is gonna take like the instance and the check, and it calls check on that instance. Then when you call PyTest, you will have like a really nice list of all the tests that are run on your estimator, and like all of them which failed with like all the like nice messages and all. But in a notebook, it's like a bit tricky to run PyTest, so like we stick with the check estimator for now. Okay, now moving on to a custom transformer. Here, what have we learned so far? We have the transformer mixin, then the base estimator, we call validate data, we return self. We are going to have a check is fitted that always returns true because this transformer doesn't really need to be fit. We are only adding one to the data. Some specific thing, like, again, why not? Some example. It looks all right. Let's run that. It says it does not raise an error when transform is called. Well, now we have two options. Do we want to call check is fitted in transform, or do we actually want this estimator to be a stateless estimator? We know how to do the former, let's do the latter. Again, that's through tags. We say my tags, I get it from my parent. And in this case, we say it doesn't require fit. And it works. Easy. Let's put it in a test. Let's put it in a pipeline. In a normal pipeline without the transformer that we just wrote, let's have a very simple one, a standard scalar and a logistic regression. And then something you might want to do if you have a pipeline and the last step of that pipeline is a predictor, you want to inspect what were the features that were fed into that last step. Imagine I want to look at the coefficients of my linear model, but I want to know what those coefficients kind of are attributed to. I can slice my pipeline, exclude the last step, and then call get feature names out on it. These would be the features that are fed to the last step. I can do that and I get the feature names. Now what happens if I add my own transformer here as a step? Do the same thing. Let's do that. It didn't work. Why? Because the my transformer object does not provide a get feature names out method. The feature names and get feature names out are still not a part of the mandatory API for a transformer. Therefore, the test doesn't exist in check estimator. You can technically use it. But if you want to be able to use this feature in a pipeline, then you have to implement that function. In this particular case, I'm not really changing the columns, like I'm transforming them, but they're going to be the same column, like a standard scalar. And I can cheat and use this mixin, which adds that to the transformer. It's a one-to-one feature mixin. Still, everything passes. And now I nicely get the feature names. And the feature names are propagated through the pipeline. Any questions on this one? Cool. Also, the HTML rep works really nicely here. I didn't need to do anything. I mean, I inherited from base estimator. That's what you need to do. Now let's do something more complicated. I want to have a meta estimator that this meta estimator times the estimator that is in it, at least the fit time of that estimator. And it stores that in an attribute. Let's see what it takes to get this one scikit-learn compatible. Let's run that, and then here I have 3 tests. I am wrapping a regressor, a classifier, a regressor, and a transformer, and I want to see like how it works. It's gonna fail for a while. The first thing is that the end feature is in. It doesn't exist. We know how to fix it if we are writing our own estimator, but do we want to do that, or do we want to delegate that to the sub-estimator? In a meta-estimator, you probably want to delegate it, which means here you can have a property that checks if the sub-estimator has it, then you return that, or we can try a hack. Today we are lazy, and we hack into Python the way that you usually shouldn't be doing. We have the instance and a name. What do we do? First, what is my estimator object here? I want to delegate to that. First thing is like here, as you notice, I have an estimator underscore that takes a clone of the input and then fits on that, which is what you should be doing. You should never be modifying your constructor arguments. So you first clone that estimator and then you do something to it and then you store it, which means the estimator that I care about when this is called is either this one if it exists. If it doesn't, then it's the unfitted one. So it's this. Or if that one is none, self.estimator. Does this line make sense? Cool.
Can you repeat, like, or explain why do you should always be cloning? I guess that you go to some statelessness kind of thing.
Yes.
But then,
as in the one of the tests that we do have, like that, if you don't, it would fail, I guess, is that if you call fit twice on an estimator, regardless of the random state. But if you call fit twice on an estimator, you should get the same result on the same data. which means you shouldn't be modifying, which also means you shouldn't be modifying your input arguments. Which is also the same thing that happens in grid search and cross-validate, like you always clone.
It's like because, for example, when you pass estimators to a pipeline or whatever, it always asks you to pass an instance, right?
Well, that's different because like pipeline doesn't necessarily know how to create the instance. Like you need to set the constructor arguments of the objects that you're passing to the pipeline. And also even check estimator, because even check estimator doesn't necessarily know how to create an instance of your object, because some of your constructor attributes might not have default values. Okay. And then here I return get attribute estimator name. And this get attribute, if name doesn't exist in estimator, it will raise an attribute error, which is what I want. But otherwise, I delegate it to my sub-estimator. Except here, it will go in a recursion if I don't add this. If name in time or estimator raise attribute error. Name is not there yet. Boo. The reason I do this is that like when is get called, it's called if Python doesn't find that attribute in your object, then it calls this one. And if it's calling me and time underscore or estimator underscore are not there, I know, well, fit is not called. I already know that, well, they don't exist. It also means this hack doesn't work if I'm looking into time underscore and estimator underscore of the estimator that I'm wrapping around. Accepting these, this should fix most of my issues now. Now, it says it didn't fail when I passed sparse data. Your tag says that you don't accept sparse. You should raise the right error. Well, that, again, comes from tags. How do I fix the tags? Again, I delegate tags to the sub-estimator. I say scikit-learn tags, return get tags self. Okay, now again, I need this same thing. So let's put that in a function. And then I can simplify this part. And I just return my sub-estimator's tags. And now it works. It's a warning, but we ignore that. Now let's see how it works. Any questions for this one?
Would it make sense to have sort of like a mixing type of thing for the tags?
For inherit, like kind of delegating.
So that you don't have to kind of hook into these underscore.
You could, but we usually, if the mixing is replacing a one-liner, we don't necessarily implement the mixin, because the user needs to either know how this works or know that that mixin exists. In terms of like information overhead that we like the user needs to know, it's kind of the same.
I was thinking more about the semantics of like going into an underscore method. It's like, okay, you're on your own kind of thing.
No, so yes, but like something that again is new in the past couple of versions is that if it starts with Dunder scikit-learn, it is public recognized. The API is supposed to be stable. We actually support you. If you complain that something's not working and you're using a Dunder method, then we should fix it. It's different from like in the old days, this would be a method which was called underscore more tags. And then it was a bit convoluted and we removed that, and this is like the new way. But An alternative way to this get_attr is that you implement every single possible thing in the public API, predict, transform, predict, proba, and features in, and you delegate that to the sub-estimator. It's going to be like a long list, and that's the kind of boilerplate. That, to me, yes, that should exist in a mixin. One of the reasons that I like giving these talks is that, like, when I give the talks, I'm like, oh, like, it would have been nice to have like that kind of mixing. And then, like, if we do that, then it could also include the tag, because it's like in the same kind of boilerplate, and it's sure like it's a mixing that everybody who is like developing a kind of a simple meta estimator that is only wrapping around a single estimator should kind of have. It makes sense for scikit-learn to have it. Now, we are putting it in a pipeline and wrapping a whole pipeline in it. So it's a timed estimator. It has a pipeline in it. And the logistic regression is also in that timed estimator. Let's call fit. And then the last step of the pipeline, it has this time underscore. It says, oops, timed estimator object is not subscriptable, because this estimator is not a pipeline, it's actually a timed estimator. One way to fix that is to say dot estimate, like that's your pipeline. Or if you really want your estimator like to behave like the object that it's including, that's what this should be doing. The get_attr, like what's the issue here? It says this doesn't, it's not subscriptable. What does this mean? It means that get_item is not implemented. So Python is looking for dunder get_item and it's not finding it. The thing is, when Python looks for attributes or functions that start with dunder, it doesn't call get_attr on them. It just says, well, they don't exist. So we have to special case that one, which means I say get_attr. It takes an index, return, again, get estimator dot get, no, not get_attr, it's get_item. We pass the index. Except that this one ideally should only exist if my sub-estimator does have get_item. We have another utility, which is, we say available if it takes a self, returns self has attribute self.getEstimator get_item. Does this make sense? This available if is a decorator that is inside scikit-learn. That's where you import it from. And it takes a function that returns a Boolean. And if it's true, then this thing exists. Alternatively, you could raise an attribute error inside your function if it's not supposed to exist. And yeah. And now, oh, self typo. Yeah. Yay! It worked. Are we clear on this one? It's a lot of mix of a little bit advanced Python and like you need to understand scikit-learn. It's fun, at least for me. So let's put this in a grid search. Again, the simple pipeline without the timed estimator. How would I put it in a grid search? If I have a pipeline, I pass the name dunder parameter, and the name by default is lowercase of the class name. And then I can train on that. It's a grid search that has this as the base estimator, the best estimator, or I can directly get the best estimator, and it's like it has my transformer and everything. What happens if I put everything in a timed estimator? It works. It's gonna be okay, except that setting the parameter here, like what is going to be the text that I pass here, that's gonna be quite complex. One way to deal with that is that in my grid, when I'm passing my parameter grid to grid search, I don't have to pass parameters to the sub objects. I can actually pass a whole list to the estimator, and this estimator is setting this estimator. What I do is I do a for loop on C, and I create a separate pipeline specifically for that C, and I pass a list of pipelines to my grid search CV. This works. This is always like a good trick if you have very complex situations where you don't want to explore the whole grid. You want to have like very complex ways of exploring subparts of the grid. You can pass a list of things that each of them is a generator, and then like it returns or it yields the objects that you want to search over. So I can do that. It works as expected. I have my best estimator, which has a timed estimator wrapping the whole pipeline, and the logistic regression is also wrapped around the timed estimator. But what if I want to pass that complex string and I don't want to have a list of pipelines? One way to find what the name of the parameter is always to call getParams on your object. It returns everything that you have. This is going to be a long list, but it includes everything. What was the thing that I cared about was this C. This is the name of the parameter in this setting for the C. I can simply copy that and put it here. Now, it's the same thing, like it looks like my previous code. I just changed this string and it works. Any questions for this part? So what are some of the conventions that we talked about? Well, some of them we didn't talk about. Ideally, fit should only take, other than X and Y, it should only take things that are sample aligned. By that we mean like sample weight or groups. These are attributes that it's one-to-one, they apply to a sample. If you have things that are not sample aligned, or like they're more of an estimator attribute that you could have set in your as a constructor argument, you should probably set them as a constructor argument. But there is no test failing on you if you don't do so. This is just a convention that we have. Init should not do anything other than setting public attribute that pretty much have the same name as the arguments that you pass to init. Everything else, every other validation should happen in fit. The reason for that is in grid search or in cross-validate, in a lot of cases, we clone the estimator and we call set params on it, and then we fit. Which means the validation that you would do in init is not run when we set the new value for the parameter in a grid search. So the validation should always be in fit. Attributes without underscore are the public constructor arguments. Attribute underscore are your fitted parameters. And if you want something private, you start it with like an underscore. And then n features in, feature names in, those are the things that store information about your data, that validate data these days, just store that for you. You don't have to deal with them manually. And we also dealt with a whole bunch of tags. In the documentation, you easily can see that like the tags are a few categories. One of them is input tags that talk about like what is my input. Do I accept sparse, which was something that we saw in one of the error messages. Does it accept categorical? All of those. And then I have target tags that talk about attributes of the target, the Y. You can set them here. And then you have the transformer tags that the only thing is like, does it preserve D-type, or what are the D-types that it preserves? Which means if I pass it a float 32, the output of transform should also be float 32. Otherwise, by default, most of our transformers return a float 64, independent of the input type. Then you have classifier tags that the one that we used was poorer score. You have similar one like for regressor tags. Like the tags just collect all of them. I put a different section here because I wasn't sure if we're gonna have enough time or I'm gonna like be too fast. We're not gonna talk about that. But There is a bunch of stuff happening. Some of it is already happened, like the metadata routing is like almost done. Some of it, like callbacks, is very much in progress. And I very much welcome you to read this document that I showed at the beginning and a few of the files in the repo. Like if you want, like really, like the documentation doesn't cover them. If you want to write your own estimators, it would be a good idea to have a look at these few files. And thank you.
Okay, so we have got some questions for you. So I think, yeah, it's one. So how should I serialize and use a custom estimator in different runtime environment?
What?
So how should I serialize and use the custom estimator in different runtime environment?
Oh, serialize it. Well, that's a different talk. But you serialize, basically people serialize using pickle or joblib dump, which is also pickle. But if you care about security, what you should be using is scops.io, which is a different library that I worked on. And it has a module that it allows you to persist and load objects. And what it is basically, what is it here? It has this almost the same API as pickle, dump dumps, load loads. Except that it doesn't actually run arbitrary code unless you tell it to. That's the safe part. So these days, I would recommend the first thing people should use for persisting is scops.io. It's much slower than pickle. It's like speed is not its priority. If you care about that and you really trust your source and destination, then you can pickle.
Okay, so I don't think we have questions here, but anyone would like to ask anything from the crowd? Any questions? Okay, then a round of applause for Adrin.
Thank you.